Good afternoon, everyone. Welcome to my talk, Who Broke the Build, using Kuttl to improve end-to-end testing and release faster. How many of you are developers here? Okay. Managers? Okay. Have you ever seen this in your teams? Okay, the manager would say, who has actually broken the build? And the developer would say, hey, I don't know, maybe it's me, but I will make sure and find out and make sure that I would fix the bug as well, okay? Little introduction about my company and probably what we do and how is it related to this talk, okay? Currently, everything runs on software, okay? Whatever that you take, healthcare, you want to book a doctor appointment, you do an online voting, okay? Maybe you use X or Twitter, something you would like to order online, okay? Transportation, okay? I book my flights online, right? And the energy, you pay your electricity bills or anything via online, right? And the backend is powered by software. Does anyone own Tesla here? Or have you tried? So during an upgrade, Tesla clearly says that you can't ride the vehicle, okay? So you can see here it takes approximately one and a half hour to do a software upgrade, okay? And during that upgrade process, you won't be able to drive the Tesla, okay? So software upgrades matter in terms of a real-time scenarios. JFrog, my company, where I represent, mission is to power all software upgrades in the world, okay? Okay, little introduction about me. I'm Ram Mohan Rao. I'm a senior software engineer, R&D, Bangalore, India. Passionate about open source and loves playing table tennis. Okay, let's start with an agenda. What a development environment would look like, what are the challenges that we had in terms of running end-to-end tests, and we figured out a tool called Kuttl. I would explain in detail, and a quick demo, and a quick summary of takeaways from this talk. Okay, so an ideal development environment would look like, say, I've used before Windows, I've used Mac, I've used Linux as my desktop system for developing. Sometimes, most of the times, what a dev would say that, hey, it works on my system, okay? If a bug is found on a remote production server, hey, I've tried to reproduce that, okay? But I haven't tested it on a system where it has actually deployed. Ideally, to fix those things or ideally to reproduce those things, a dev environment should be very similar to a production environment so that an issue that is probably going to happen in a production environment can be easily be tested before it goes to the production, okay? So most of the time, say a new developer joins your team, wants to set up their environment. Roughly, I've been with companies where they would have a manual instructions to set the environment up, look up a Confluence page, and then do the instructions, copy those scripts, and run those scripts to do that. What we do at JFrog was to have a single-click automation so that everything clone that repository, run that script, and it should set up your environment. And what we feel is a developer should be empowered to start probably coding from day one, instead of trying to set up everything on his own, okay, looking up a documentation or other things. And more importantly, if a feature is developed locally, he should be able to test it locally. Most of the time that doesn't happen in an end-to-end scenario where he writes some unit test, runs those tests, but an end-to-end test is a real pain, okay? So I've already talked about setting up a manual instructions, which can be completely automated using scripts. Benefits, instead of taking minutes or hours, the earlier manual approach, it can be, the entire setup can take minutes. No manual steps would mean error-free. And also, if you would like to test those features, you should be able to quickly deploy it, okay? So that you change or a build, test it locally, and then probably make a pull request. As I said, a dev environment should be very similar to production environment. It saves a lot of time in terms of reproducing the issues. Okay. Sorry, I'm having a bad throat. So most of the development teams where they work on a feature development would follow this process of taking the requirements from a product manager or somebody, design it, then start the development on a feature branch, write some unit test on the code that he has written, and locally test those unit tests, commits, and push to a Git repository. Generally, that's the thing that you do. Okay. So problem with that thing, when you have those tests remotely, say end-to-end test remotely, what happens is you write the code and you raise a pull request, and then the testing happens on a remote CI/CD systems like Jenkins or some other pipelines. The time to react to the development of a bad commit is huge in terms of pushing those round trip, and say if something fails on a end-to-end test, first he needs to understand why it failed. The reason might be an environment issue on that side, maybe a code issue as well on the feature that is being developed. So this round trip is something that pains the developers, okay? How can, the main problem I would say is running these tests end-to-end at a remote server, okay? How can we actually avoid this, okay? So this is where generally a development happens, writes unit test. If everything is good, he raises a pull request. And on that pull request, the remote CI/CD server or the Jenkins would trigger that. And if something fails, that notification would come. Sometimes these end-to-end tests takes hours or sometimes days to run the entire suite of tests, okay? So the feedback loop for a developer to check why it failed is huge in terms of it. So instead, can we actually leverage some tool or something where these end-to-end tests can be run locally, okay? We at JFrog thought, hey, this is a little pain to our developers, so we would like to leverage some solution in terms of running these tests locally. So what would happen when that happens? Instead of running remote end-to-end test, you can run it locally, which would mean you locally commit instead of pushing those changes to a remote server. Run this entire suite of tests locally. So when that happens, you run those tests locally, then you just need to amend those commits, okay, in terms of figuring out something issue with the code or something fails, okay. This way reduces the round trip of pushing to a Git repository, running those tests and other things. So what we did was, instead of running those remote, we are running those end-to-end tests locally. But we had a problem. Hey, how can developers set up that entire infrastructure of a remote end-to-end test, which is configured on a Jenkins or a remote server, to come back to this? So we were evaluating a couple of tools, okay? Fortunately, most of our development is on CloudNative, okay, on Kubernetes and other things. So we were very specifically looking at some tools that could help us. So we figured out a tool called Kuttl. Kuttl is an open source CNCF gowned tool. Kuttl comes from a history of a Kudo builder. Kudo builder is a project that is used to test the operators, Kubernetes operators. They've written Kuttl as a framework to test those operators. But Kuttl can be extended to any, Kuttl is Kubernetes test tool by definition. So primarily used for testing operators. It is initially designed that way, but it can declaratively test any Kubernetes objects, okay? Or any objects, I would say. Very specific to Kubernetes here, but it can test anything. I would show you with the demo. It's an YAML based. I mean, most of the developers here come from different Java background or Golang or anything. They just don't need to learn a new framework here. It's an YAML based, very simple to understand as well. And it also has an ability to create an infrastructure around creating a namespace and then destroying it as well. I would show it with a demo. So to get started, if you are using a Mac or Linux, Mac users can just do a brew install Kuttl CLI. Linux users can use kubectl crew install Kuttl. And if you are an API developer or using Go, you can still integrate Kuttl in terms of Go, GitHub, kudo bidl Kuttl. My talk is more based on the CLI-based approach, okay, not on the UI-based thing. So I would ignore this API integration thing during my talk. Okay, so what Kuttl is for? Kuttl is for an application admin who wants to automate the creation of a new Kubernetes environment. Say, for example, I am a developer. I have a build where I would like to test on Kubernetes. Okay, my main agenda is that. Okay, so setting up a infrastructure for Kubernetes using a Golang or a Java based is little difficult. I wouldn't say not possible, but it's little difficult in terms of creating a namespace and then setting up those environments and other things. So Kuttl makes life easier. And if you want to test, say for example, Kubernetes would release each GA version of it every 6 months, okay? And you would like to test your applications on different versions of Kubernetes, okay? Say something breaks or something new feature has added, some V1, beta 1, an API changed or something to do with it. And if you are a developer, you would like to test without writing Go code, okay? Say for example, you come from a different background and you would like to test something which is not familiar earlier, okay? So Kuttl has 3 main configurations, I would say. Test suite. Test suite is a collection of test steps. It's a, you can see an API version Kuttl dev v1, beta 1, and a kind as a test suite here. So you can see start kind as false. In my demo, I would set it as true, which would mean I'm using a local Kubernetes cluster called kind or a minikube, whatever you can reference as. And I would like to probably demo an application install, okay? And to see if it actually works. You can extend it to an API where you can call an API and get a request and response and do an assertion based on that. So test suite is a collection of test steps, okay? And more important thing is it has a timeout. Say for example, you would like to deploy your application and you set a timeout of 300 seconds here. And if your test pass within that 300 seconds, it would run successfully, okay? Otherwise it would fail if it goes beyond that, okay? As I said, suite is a collection of test steps. Test step is another CRD, okay? Custom resource definitions with respect to Kubernetes. You don't need to get into that aspect of it. Just think it as a test step where you can configure your execution of commands as a simple commands. So if you are using an existing tool to run your end-to-end test, Kuttl can be integrated. You can call that execution of the shell script using this test step. So that Kuttl will create the infrastructure for you and you can run those tests. Okay, and the next thing is assertion based on that test step. Say first you would like to deploy an application here and I would like to do an assertion whether that stateful set application runs and installs with read replicas as one, okay? So declaratively testing this using Kuttl. So you define that I would like to install and then do an assertion based on that declaration, okay? It automatically does the assertion based on this assertion file. So you can see the test complete structure of Kuttl where I have a demo application. I have 2 tests. Kuttl test.yaml is the suite file that I was referring to. Okay, let me quickly switch the context of here. Okay, I have a live demo where I would like to set this suit, as I've mentioned, I've set the kind cluster as true, okay, which would mean if you are running a Rancher desktop, you can, or a Docker desktop, you can set that context to Kubernetes to use that local cluster, okay? And if you set it to false, you can use an existing Kubernetes cluster, EKS or external GKE clusters as well, okay, based on that. And for the sake of demo, what I've done is I'm trying to install Artifactory OSS open source version of it. Since the downloading of images takes a little bit of time, what I've done is I'm preloading those images, and Kuttl provides that option as well, where you can download those images previously. And also, it also provides a node cache as well. Okay, you don't need to do entire stuff of this, where you can set the kind node. First time it would tries to download those images and put it in a cache. Okay, next time when the subsequent runs happens, it would be much faster. Rather than re-downloading those images, it would fetch from the cache itself. For the sake of demo, I've actually preloaded it. Okay, so I'm connected to the internet. I would disable it. Hope that is okay. Okay, and I would like to quickly run a demo so that everything happens from my local. Okay. Okay, let me do a tree structure of my thing, or let me quickly switch back. So I have an application called Artifactory OSS. I can actually, I've pre-downloaded that chart, a Helm chart, and Helm chart is a packet manager. Helm is a packet manager for Kubernetes where you can actually install that. I'm having a chart, I've pre-downloaded it. I have two tests as part of it. One is a default install thing, where I'm trying to install Artifactory, okay? There are two modes of installing Artifactory, with a split mode and a non-split mode. I'm trying to deploy this application, simple. And then I'm doing an assertion based on it, okay? It can be extended to call an API. In the assertion, you can put a response that you expect to happen, okay? And if the response matches with the request that you are passing, it would assert successfully as pass, okay? And I'm used timeout as 1800. I don't need that. It would probably finish it in 2 minutes, okay? Since I've pre-downloaded the images. Okay, so let me quickly run that Kuttl test. Simple command, kubectl, Kuttl is a plugin kind of a thing, and test, okay? So what it does is, since I've set the start kind as true, it is using my Rancher desktop that I have, okay? It's the Rancher desktop that I'm using. So it starts that local Rancher desktop kind cluster locally using that Docker daemon. You can see starting the kind cluster. So let me do the export of that kubeconfig file of that thing so that I can access via an open source tool called K9s. I would explain in detail. Okay, so you can see it is trying to load the containers to the kind, since to the control plane of the kind. Okay, since the Kubernetes has the control plane thing, it is actually prefetching those images that I already have into that kind control plane. It would take less than a minute. Let me quickly. So there is an open source tool called K9s where you can access this Kubernetes clusters using a graphical user interface, okay? Or you can do in a harder way of kubectl to get those interactions. So as you can see, it is loading those images that I need for this demo. If not, if I don't specify this, it downloads from the internet directly, okay? It would take some amount of time. So you can see it clearly. Okay, this is an log setter. I mean, you can ignore this. This is from the Kuttl itself. You can see it is trying to fetch. Okay. Okay, so there are two tests that it has detected. One is non-split and a default install. You can see the Helm command that I'm running over here. Okay, OSS this thing with split services to container false and true. Okay. So there are two namespaces that it creates automatically, okay? Let me get into those namespaces and see you can see here, these images are already been pre-downloaded. So it is starting the Artifactory in a non-split mode, which would mean it's a monolithic application where you can have all the services into a single thing, okay? So let me go to the other namespace. You can see Artifactory. Artifactory has different microservices. You can use this mode of actually installing it as well. So it would take at least a minute for the Artifactory to start, and the assertion would probably kick in and assert that the install is successful or not. Earlier, we were using Helm testing tool, a CLI tool. The problem with that tool was it doesn't support concurrent parallel testing, okay? So you had to wait for, say, you had 20 tests, okay? So each test would probably take 10 minutes, okay, roughly. Then the entire test suite would take probably 1.5 hours for us to verify that everything works. With switching to Kuttl, what we have it provides a parallel support as well, where you can run by default 8 parallel tests. So here we have 2 tests. 2 tests are running parallelly. So the entire test suite that was earlier that we had for 1 hour 30 minutes were reduced to something like less than 20 minutes now. Okay. So you can see here, the namespaces are getting terminated after the tests were successfully run. So you can see both the namespaces that we had were terminating, and so Kuttl would also provide a way to get the report what successful tests were run. Okay, so you can hook up to your CI/CD solutions to say which tests ran successfully, which tests did not pass in. Okay. So you can see here, it is deleting the namespaces. It is clearing the entire local kind cluster as well. This is where Kuttl is helpful. You don't need to worry about the infrastructure. It creates and it destroys it. You can see it has successfully run 2 tests. You can ignore this because this is actually the code that I had. 2 tests ran successfully. So what does it mean is I'm testing everything locally without the internet as well. Okay, everything is coming in. So you are pretty sure that your code or the changes that you have made successfully runs locally. So when you raise a PR or a pull request, it is pretty sure that your code doesn't break the build. Okay, that's the more important point that I would like to highlight here. Okay, we had many broken builds. Whom to blame was the question, but with this Kuttl thing, we were happy that developers were happy to not have everything runs locally. Developer runs these tests locally, and okay, let me switch back to the presentation. So these are the references that I have. Kuttl is an open source. Okay, let me quickly go over this time if I have a couple of minutes. Okay, so there is a Kuttl dev documentation around this. As I said, this is part of the Kudo Builder thing, which is active. There would be releases every couple of months with all the features. Okay, there is a dedicated Slack channel in the Kubernetes thing called Kudo. And there is a tool called K9ice. This is a GitHub reference for that. Okay. Okay, quick takeaway. Open source tool. Kuttl is used for local testing, which enabled us with few broken builds, which were, since it was taking 1.5 hours for entire suite of testing, we were able to finish it in less than 15 minutes or 20 minutes, which would mean faster releases cycles. Developers were happy. Okay. Any questions? Sure.
I have a question. And how exactly look like the test report after the test is finished?
Okay, let me switch back. So Kuttl provides 2 options where you can define a JSON-based or an XML-based report. Okay, so the report that defaultly would be an XML or a thing where you can specify the JSON as well. So it parses all, say that you have 20 tests. Okay, say 18 tests passed, 2 tests failed due to some XYZ reasons. So it would show you why the test has actually failed as well. With the report. So everything is detailedly documented in this Kuttl.dev thing with all the use cases around this thing as well. So kindly go over this thing, Kuttl.dev, where you can get CLI usage, harness, tips and tricks, API integration that I did not cover, CLI usage, and more. I mean, if you have a feature request, probably you can raise it as part of a GitHub as well. Did I answer that? Thanks. Any further questions? Okay, that's all I have. Thanks for your time.